you talking about other things that he's been doing to add lots of colors to your web browser and your programming environment.
Oh, hi again. So I'm going to be talking about another set of colored boxes here. And what I'm going to be talking about specifically are the colored error highlighting in WeScheme, this online programming environment that I've been building. So let me first introduce what the problem. So when students program, they don't write perfect programs. They often have programs that produce errors. What we found, or at least what Guillaume Marceau has found, he wrote a study on this in 2011, is that students actually don't understand the vocabulary used in error messages. This is a big problem because if they don't understand the content of their messages, they have no chance of fixing their program. So one suggestion that he made in his paper is that we can teach vocabulary through pointing. More specifically, for all of the nouns in the error message, we can somehow get it so that way we display a correlation between the nouns in the error message and what they're pointed to in the original source document. And one way we might do that is to use color for that. So let me give you an example to more concretely show what we mean about this. So we mark this up. Say, for example, we had this particular error. As you can see, each of the referents are being colored with a colored background, and it correlates to the same color in the source text. And in this way, we hope that students can understand that when we say argument, we mean that thing there. And when we say that they're providing two arguments, we mean those two arguments right there. So that's one example. And we might be able to use color in more substantial ways. For example, we might be able to say these related set of arguments and show that there's a relationship between them through the use of gradient color. So here we say those 7 arguments, and these are the 7 arguments we were talking about. And of course, we don't just want to catch runtime errors this way. We also want to be able to catch compile time errors and show and use the same techniques here. So here we have a reader error, misbalanced parentheses, and we want to use those 2 colors there. And we want to highlight the individual left and right pens. Right. So as good how to design programmers, we should start with the data definition. What exactly are we talking about here? Well, we want to use an error message, and before an error message used to be just a string. Right? Let's expand that. So we're also going to say that an error message can also be a colored part which contains the string text and a set of locations in the source. Or we might say that that it also includes a gradient, which itself contains a list of the colored parts. So once we have this data definition, all we need to do now is just change WeScheme, compiler, and runtime. It's a small matter of programming. So let me show you a little bit of what that involves. At the compile time, we want to generate these structured error message values. So we went through the WeScheme compiler, changed places that look something like that, where the ... is some arbitrary is some string, and we added additional structure into it. We improved the state of the error messages in WeScheme. And at runtime, we made changes in the compiler so that way it would provide the runtime some information. In particular, whenever we're doing a function application, we added onto the control stack the positions of the operators and the operator and operands, so that way if an error occurred, we might be able to more precisely point out at runtime. So we took something like f of x, y, z, and we changed our compilers that way it would generate that. And if you're familiar with Racket supports the notion of continuation marks, which lets you install values onto the control stack, which you can then later query at runtime. So let me give you a demo of what we have. So this is WeScheme. I'm not sure if you've seen this before, but it looks very much like Dr. Racket, and we are going to try the example that motivated this. So if I run that, right? And just to make it more clear, I can click on this in order to see what are my 3 arguments right there. right? And if I misapply a function that way, I give it too many arguments, I get the proper highlighting. We're also doing runtime checks, of course. So if for example, we divide something by 0, we can say, whoops, let me comment out the. If I divide something by 0, I can say, where did the 0 come from? It came from right there. And so on. So we have this running in WeScheme now, but of course we need to iterate the design some more. In particular, we don't have a story yet of what to do with higher order functions. If a higher order function misapplies, we don't really right now have a way of pointing at the source of the higher order function. It's not in the program source of the student. So we need a better story of how to handle those. And of course, we have to measure the effect of this. This change in error message structure and how we present these error messages to real people. We really do need to do some measurements there, and I'll be modifying WeScheme accordingly to try to get real data on that. The source code is available online on GitHub, so both the WeScheme, the environment, and the compiler are available there. And so I just want to end with a few lessons that structures are really helpful in this, and that how to design programs in a sense. One of the core lessons is that flat data is fine, but we shouldn't be afraid of structures. I also don't ever estimate undergraduates trained in how to design programs. I basically supervised this work, and they worked really well at it. At the same time, you also have to appreciate the destructive power of the Olympics. So yeah, they got a little caught up every once in a while. But yeah, I want to give special thanks to them, and definitely want to thank Sharma and Kathy for letting me spend so much time with them at Brown and at WPI for all these years. So I'm ready to take questions.